Exponents and powers, probably the most confusing chapter with you students because of the exponents, powers, and the negative sign in the exponents. That makes things, really confusing. But the truth is, the entire chapter is basically based on 4 laws. I am JP Dutta and you are with Have Fun and Learn, and today we will have a crack at RS Aggarwal exercise 2A exponents and powers, and let's get going. Please keep your copy handy so that the moment you learn the logic and the dynamic behind these laws, you'll start from solving these problems in seconds, right? Don't forget to subscribe, share and comment. Let's go over to the solution. So question number 1, part 1. So evaluate 4 to the power of negative 3. So we know that a to the power of minus m is equal to 1 by a to the power of m. So we apply this rule here. This will be equal to 1 by 4 to the power of 3. Right? Since they have asked to evaluate, you write down 1 by 4 times 4 times 4, which gives you 1 by 64. Right? The common mistakes that people make is the minus 3 times 4, which is wrong. Again, 1 by minus 3 to the power of 3, again wrong. So these are the common mistakes that are made, correct? Now we come to question number 2. Same law we apply here. We make the exponent positive, like a to the power of minus m is equal to 1 by a to the power of m. Similarly, we do this. So what will happen? 2 to the power of 5 or 2 by 1 to the power of 5, which is equal to 2 to the power of 5, right? That is 32. Correct? Now we come to question number 3. What we do is here, we make the power positive by writing 3 by 4 to the power of 3. If you remember, we did in a previous video that a by m to the power of m is equal to b by a to the power of minus m, right? So that's what we have applied here. Now see, since it's evaluation, so we would write 3 times 3 times 3 divided by 4 times 4. Now we come to question number 1, part 3, part 4 and part 5. So part 5 will be, we'll make this power positive, right? Saying that a to the power of minus m is equal to 1 by a to the power of m, right? So it becomes 1 by minus 3 to the power of 4, correct? Now if you simplify it, it becomes 1 by minus 3 times minus 3 times minus 3 times minus 3, right? Which is 1 by 81. It becomes positive, right? So now we move on to question number part 5. So again we have got a by b to the power of minus n is equal to b by a to the power of n. So we apply this here. So we'll make the exponent positive. We'll make this positive, right? So what we have? Minus 3 by 2. We have 3 by minus 2 to the power of 5, right? So if we evaluate it, we get 3 times 3 times 3 times 3 times 3 divided by minus 2 times minus 2 times minus 2 times minus 2, right? So we get here 243 divided by, this is minus 32, correct? And which is same as minus 243 by 32. Now we come to question number 2, part 1, part 2, part 3, right? So evaluate this. Now see, we know that a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. So the bases are same. Here also the bases are same. So we can apply this rule. So we get 5 by 3 power 2 plus 2, which is equal to 5 by 3 power 4, which is 5 times 5 times 5 times 5, 3 times 3 times 3 times 3, which is 625 by 81. Correct? Now we see here. Now, in order to keep things simple, since the bases are same, we do not make the exponent positive. We keep it intact, so that we can write 5 by 6 the power 6 plus of minus 4, which is 5 by 6 minus 4, that gives you 5 by 6 power 2, which is 25 by 36, right? Understood? Now we move on to part 3. See, here again the bases are same, but since they are same, and we can make the power positive, so like we can write 3 by 2 power 3 times 3 by 2 power 2. That gives you 3 by 2, 3 plus 2, which is 3 by 2 power 5. Correct? Now you calculate this one. I've done so many, now you do this. Correct? So this is where I made the index positive, because the bases would remain the same, and I can apply a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n. Number 4 completes the main part, question number 2. So here again, see, the bases are same. So we write 9 by 8 power minus 1. So we make the power positive and write 8 by 9. So the answer is 8 by 9. We come to question number 3, part 1 and part 2. See, here we got to remember two things. 9 is equal to 3 to the power of 2, and anything to the power of 0 is equal to 1. Correct? So what we do, we make the first this index positive. So 9 by 5 power 2 times 5 by 3 power 3, and this is equal to 1. Right? Now we replace 9 by 3 to the power of 2. So 3 to the power of 2 by 5 power 2 times 5 by 3 to the power of 3. Correct? Now see, we distribute the powers. How? 3 to the power of 4 divided by 5 to the power of 2 times 5 to the power of 3 divided by 3 to the power of 3. Correct? Now we bring in all this together in same place. 3 to the power of 4 divided by 3 to the power of 3 times 5 to the power of 3 divided by 5 to the power of 2. Right? Now we can apply the division rule. So 3 to the power of 4 minus 3 times 5 to the power of 3 minus 2, which is 3 into 5 is equal to 15. Now coming to question number 2. So we make the index positive. So 5 minus 3 to the power of 4. Now I distribute this power, minus 2 to the power of 2 divided by 5 to the power of 2. Agreed? So we can write this as 5 to the power of 4 minus 2 divided by minus 3 to the power of 4 times 4. Correct? So this gives you 5 to the power of 2 divided by minus 3 power 4 times 4. So if you calculate it out, you get 25 times 4 divided by 81. Right? So 100 by 81. So that solves question number 2, part 2 of question number 3. This is what you got. So we make the powers exponents positive. So 3 by minus 2 power 3 times 3 by minus 2 power 2, right? Now the bases are same and the powers are also positive. That makes things simple. So we write 3 to the power of 3 plus 2 divided by minus 2 to the power of 3 plus 2, which you get 3 to the power of 5 divided by minus 2 to the power of 5. That gives you 243 divided by minus 32. Minus 243 by 32. That's all. So we come to question number 4, part 1 and part 2. See here, the brackets are to be opened with board mass in mind, right? So we'll first take out the second bracket and write as bracket minus 2 by 3, 2 times minus 2, correct? Second line we write minus 2 by 3 minus 4. Now we make the index positive, minus 3 by 2 power 4, right? And that gives you 81 by 16. Now here we have got 3 brackets, 1, 2, 3. So we'll first take out this bracket, third bracket. So if you take out the third bracket, we write second bracket, then minus 1 by 3. These powers remain same, but this one gets multiplied with minus 1. Correct? So we write second bracket, minus 1 by 3, power 2, and this becomes positive 2. Now we open the second bracket. So we write minus 1 by 3, 2 times 2. So that gives you minus 1 by 3 power 4, which is 1 by 81. We come to the last part of question number 4. So again we take out the bracket from outside. So it will write as bracket 3 by 2 minus 2 times 2, and that will boil down to 3 by 2 power of minus 4. We make the indices positive, 2 by 3 power 4, which is 16 by 8. We come to question number 5. So be careful here, right? There is a negative sign, please check. So be careful. So first of all, what we do is make the index positive. So this becomes 3 to the power of 3 minus 2 to the power of 3, close bracket, divided by, we make the index positive, 4 to the power of 3. We can always do that, right? It is bid mass. Brackets after that index. So you get 27 minus 8 times 1 by 4 to the power of 3. Correct? So in that case you get 19 times 1 by 4 to the power of 3, which is 19 by raised to 19 by 64. So I hope this explained whatever confusion you had should be popped. Confusion should be popped. And by the way, you are with HaveFun&Learn, and I am JP Dutta. Please subscribe, share, and comment. And in the next class, we pick up again exercise 2A from question number 6. Till then, bye bye.